Hello everyone and welcome to this short video on micrometers. The schematic you have in front of you is of a micrometer screw gauge. Micrometer screw gauges are devices or measuring tools that we use to measure very precise to make very precise measurements as precise as 0.01 millimeters. Obviously, as is the case with all measuring instruments, an increase in precision comes with the disadvantage of a decreased range. So similar is the case with the micrometers. Despite having a very high precision, the range of the micrometer only falls about 0 till 2.5 centimeters, meaning that the maximum object the micrometer could measure would be 2.5 centimeters. Beyond this, an object could not be measured through the micrometer, and for that we would need vernier calipers or meter rules and other instruments. A little bit labeling about the micrometer would be that this portion or this circular scale we have with us is known as the thimble. This thing, this scale is known as the main scale, and after the main scale we have with us these jaws. So these two are the jaws of the micrometer, and they open up, and that's where the object actually fits in. So the object is placed between the jaws, and the thimble is used to open the jaws, and the main scale and the thimble give us the reading of the micrometer, what the measurement or what the length of the object might actually be. So this is a working schematic of the micrometer, and as you could see, this is the thimble, the main scale, and then the jaws, which aren't shown in the above diagram, but you could see in the diagram below. To open the micrometer, we can't just pull the thimble towards the right. We can't just pull it towards the right. Rather, what we have to do is we can rotate it. So if we rotate the thimble downwards, so for example, if I start moving this thimble downwards, so if I'm moving it downwards and if I'm looking at this direction, this movement might be counterclockwise. So if I'm rotating the thimble counterclockwise, the thimble would move, and the thimble would move towards the right, and the reading on the main scale would increase. This is how the reading on the main scale would keep on increasing. Now, if you could see that the shortest distance between any 2 points, this first point and the second point, uh, these 2 points is about 0.5 mm. So from 0 till this point, the distance is about 0.5 mm. And if I keep rotating the thimble with if I give it another rotation, now I'm at another point which is another 0.5 mm apart, which is at 1 mm. Now if I rotate the thimble again, so then the thimble would move on another 0.5 mm, and I would come to the point where the reading on the main scale is 1.5 mm. So I could keep moving this, and as you could see, the jaw would keep on opening up. So the jaw would keep opening up until I could place an object inside it, and once the object has been placed inside it, I would tighten up the jaw by rotating the thimble in the opposite direction, which would be clockwise in this case, until the jaw uh, has completely shackled the object, and the object can no longer move. That's when we know the object is fit in. Now what we do is, at that point we try to take the reading on the micrometer. So how do we do that? We'll come to that, but just to recall one thing, if you notice that if my thimble is at 0, so to move from 0 to 0.5, the thimble has to complete one rotation, and one rotation includes 45 mics on the yeah, thimble must complete one rotation, and to complete one rotation, the thimble must go 45, 46, 47, 48, 49, and 50. It should retain around 50 points or 50 readings. Only then it moves 0.5 mm on the main scale. So now this is where we were initially, and now coming to a enlarged image of the micrometer. This is what the micrometer reading shows, and this is assumed that this is the point where the micrometer has completely has a the jaw has the object which whose length we need to measure completely fit in inside it. So we need to take two readings, one of the main scale and one of the thimble. So if I go with the thimble, go with the main scale first, I know this is 0 mm, and I know this is 5 mm. Anything between them, this is 1 mm, this might be 1 mm, then I have 2 mm, then I have 3 mm, then I have 4 mm. And obviously the readings in between 0 and 1 mm would be 0.5, and then 1.5, then 2.5, 3.5, 4.5, 5.5, and so on 6.5. So this would be 6.5, and obviously this had been 5, a 6. So we take the last reading we could read on the on the main scale. In this case, the last reading I could take is 6.5, because beyond that, like, the micrometer is now between 6.5 and the next reading, which was supposed to be 7 mm, 7 millimeters. So this is the reading on the main scale, and we write it as 6.5 millimeters. Now we need to find the reading on the thimble. So to find the reading on the thimble, we take the center line which we have with us and see where this line intersects the readings on the thimble. So this line is approximately intersecting this line, which is 11, 12, 13, and 14. The reading comes out to be 14. So the thimble reading comes out to be 14. Now, there are two ways to do this. One way is through the principle, by knowing the principle of how micrometer works. So we know that the micrometer had, or the thimble was supposed to move 50 readings, so that it could move 0.5 mm on the main scale. So now, similarly, if the thimble has moved 14 points or 14 readings, how much would it move on the main scale in this case? That would be my x. Now what I would do is I would cross multiply these things, and this would give me the following equation: 50x equals 14 multiplied by 0.5, and similarly x would be equal to 14 multiplied by 0.5 divided by 50. Obviously the 50 was dividing the whole thing, but I could write it there as well, and this would be equal to 15 multiplied by 0.01, and this would give me 0.14 mm. So this tells me how much would the thimble have, would it reading of 14 on the thimble means that it has moved on the main scale. So after 6.5, the reading on the thimble was 0. When it moved 14 points or 14 marks on the thimble, it has moved around 0.14 mm towards the right, because obviously had it moved 15 readings, it would have moved 0.5 mm. So now if it has moved 14 readings, it has moved 0.14 mm towards the right. So now we got how much this distance, or the distance between the thimble and the main scale reading of 6.5 actually is. So this is the reading of 6.5 that we actually had with us, and this is the thimble, and the distance between them, this distance, just turned out to be equal to 0.14 mm. So 0.14 mm was the distance that turned out to be between them. So what we do now is, we know the main scale reading, which is 6.5 mm. We add the reading which we found on the thimble, which was 0.14 mm, and this gives me an answer of 6.64 mm. This is the final reading on the micrometer, and as you could see, it's accurate to 0.01 millimeters. The precision of the reading is to 0.01 millimeters. Now just one thing, if you had noticed in the formula, it was x equals 14 multiplied by 0.5 divided by 50, and then x was equal to 14 multiplied by 0.01. 14 was the thimble reading. Thimble reading was 14. So in other words, I just multiplied the thimble reading by 0.01, which gave me the final answer. The displacement of which gave me the actual movement of the micrometer in the main scale after the 6.5 mark. So instead of doing this whole cross multiplying thing, a convenient way to do is just to whatever the reading is on the thimble, let's say the thimble on the reading on the thimble is 35, so we just multiply 35 with 0.01, and this would give us 0.35 millimeters. So this is another way. Instead of the cross multiplying, we could just simply multiply with 0.01, and we could get how much it has moved from the last possible reading on the main scale. So we add the values and we get the final result. So I hope this was clear to you. The video